So before we do the next work for the afternoon, we need to understand what a thing called a binomial is. Okay, so let's go over that. We have this new concept that we studied a while ago, and this is the goal of today's topic. So today's goal is to get ready for polynomials, okay? So now let's talk about what a term means. So we had just done what we were looking at for quadratics, but we didn't really talk about it. We just looked at certain things like the exponent on a term. And you kind of understand what a term is, but now we're going to make sure we understand what it means. So here are the parts of a term. All right, so when we have the parts of a term, let's say I have 5x to the, say, 2, okay? Now, this part here is called the exponent part of a term. This part here, this letter part, I'm going to put it in blue. This is called the variable. And the reason why it's called a variable is because we can change that letter to a number at any time. Now, the stuff that's in green here that I'm circling, we call this the coefficient, coeffient, coefficient. There it is. We call it the coefficient. So now there are many different types of polynomials. So let's go over those basic names. All right, so when you talk about polynomials, right, we're talking about basically the number of terms. So let's say I have one term, okay? We call this a monomial, okay? Now, an example of that would be 5x squared, or the number 5, right? That's a monomial. So now if we had, say, two terms, right? You don't call this a two-termial. You call this a binomial. So think of it as like a bicycle, right? You wouldn't call it a two-wheel moving machine. You'd call it a bicycle. Bi meaning two wheels, two cycle wheels. So in this case, an example of a binomial would be 3x plus 2. You've seen them. Aren't those lines, man? That's amazing. So the next type of polynomial that you can get is a three-term polynomial, and we call this a trinomial. Anything that has three terms. So let's say I have x squared plus 6x plus 1. That is a trinomial because there are three distinct terms, i.e. x squared is not the same as x, which is not the same as 1. So all of those three terms, unique terms, make it a trinomial, okay? So the last thing is, imagine if I have any number of terms, right? We call this just a polynomial. So don't worry about that. I'm not going to talk about that. Just understand all of these three things are called polynomials, but their unique terms within polynomial is monomial, binomial, and trinomial. Monomial meaning one, binomial meaning there are two distinct terms, and trinomial meaning there are three distinct terms. Now take a moment, copy that down, and then we'll move on to the work for today. So now let's talk about my favorite thing. It's called mathematics with brackets. Oh boy, these things are always difficult. So we need to be able to do things like multiplying monomials, okay? And collecting like terms and applying a thing called the distributive law. So let us practice that. So for our homework today, you're going to see this. So these things are going to be are very similar to question number 3 from your work and question number 8 from your work. All right, so here's your first example. Let's say I have 5x times 3x squared, right? The key is this. If I'm multiplying, you're going to get the following. 15x cubed. Now, how the heck does that happen? The reason why that is because if I take x times x squared, this value of x on the top here, that's outside, is a power of 1. And when we're doing our multiplication, we basically just add the exponents. So 1 plus 2, which gives us a value of x to the 3. So we have x times x squared gives us x cubed. Now, for the second half of the problem, you have to take 5 and multiply it by 3 to get the coefficient in front, which ends up being 15. And that is where we get these numbers. So this goes to here, and then this part changes to this. Okay? So now, the next thing that we have to take a look at is what would happen if we actually multiplied, say, two terms, multiplied or squared them. Okay, so the next example is if we're going to square a term. So let's say I have this, 3x squared. Let's go negative 3x squared. So in order to actually do the application, what you have to do is you have to start by doing this, negative 3x times negative 3x. Now, this problem turns into something as simple as this one. So we follow the same pattern as before. So x and x, when you multiply them, x and x is x to the 1 times x to the 1, which is really x to the 1 plus 1, which is just x squared. So we end up with x squared, but our coefficient, the 3 and the negative 3 and the negative 3, we're just going to multiply those together. So negative 3 times negative 3 gives us positive 9. So you can use your calculator to either write it as negative 3, or you put it in the calculator and write negative 3 squared, which gives us 9. Both of these are valid when you're doing your calculations. So we end up with 9x squared, and we're done. So the next concept that we need to do is we need to collect like terms. Let's talk about that. All right, so this is what we would do for question number 4. We're going to be collecting like terms. Let us try this problem. So now, imagine I have this problem, okay? I want you to imagine that you have to collect all these things that are like terms. Well, in order to collect like terms, what you have to do is you have to make things that look the same, i.e. the terms are the same, the variables are the same. Those things need to be put together, okay? So if I'm looking at this problem here, 5x squared plus 4x minus 3, and then 10x minus 2x squared plus 9, the key is to look for the terms that are the same. And you'll notice, I'm going to highlight them in green. Notice I've got 5x squared, and then I've got minus 2x. So what I can write is 5x squared minus 2x squared. Okay, so you put those two together. Then we go and find two more terms that are similar, i.e. 4x, the x squared term, the x terms. So just the x's, so stuff with just a power of x, are this. Notice I'm also circling the positive signs as well, right? So now we have 4x. So we have plus 4x plus 10x and then plus x, which is really, remember, 1x is really just 1x. So we're just going to basically put those two together, 1x. And then we're going to add our 9. And then we're going to add up the rest. So we still have a minus 3 and a plus 9 left over. So we tack those on to the end, as we see right here. Okay. And right here. Okay. So now we add up all our terms. We add up our terms which have similar variables. So we have 5 squared minus 2 squared, which is really just 5 minus 2, which is just 3, but we still have to put x squared. So now we're going to do the same for this bit here, all the stuff in red. So we just add up 4 plus 10 plus 1, which gives us, you guessed it, positive 15x. And now we add up the last part, minus 3 plus 9. So you punch that in your calculator. Minus 3 plus 9 gives us plus 6. And there is our answer. And we're done. That's it. So now let's talk about the homework. So the homework you're going to actually submit for marks. We're not going to you'll be tested on it inside a lesson, but if I see that you have a problem on your test, I will replace that mark with this mark. So here's what you're going to do. It's going to be out of 10. It's going to be out of 10. And your job is to do as much as you can and show me all your work. Show all steps. Okay, so you're going to do homework 3.2, 5.2. So you're doing homework 5.2, and you're going to be doing number 2, number 3, number 4. Okay. And that's it. Number 4, and let's see here. Number 4 and number 7 and number 8. And you're going to do, for 8, you're going to do B and C, and we're good to go. So all of these questions are based on the material that we just did. So just work through them and see what you get. Okay? Good luck. All right.